In this video, we want to start having a look at motion. And we're going to focus specifically on calculating the average velocity and speed of a particle. So before we start doing that, we need a couple of definitions. So first off, if a particle is moving along in a straight line, we say that its position is varying with time, and we use t to represent time. So the position of that particle is what we call the displacement. So displacement, represented by x, measures the distance of a particle from a fixed point, so its starting position. So it's saying, is it in front or behind or equal to where it began? So what that means is that motion can be described where x, or the displacement, is a function of time. So we can write our displacement is equal to f of t. So let's have a look at an example. This example is from your textbook, so Cambridge Pender. So what it says is, for example, suppose that a ball is hit vertically upwards from ground level and lands 8 seconds later in the same place. So it's going straight up and straight down. It says its motion can be described approximately by the following quadratic equation. So that's this equation here. And this is a table of values describing the displacement at particular times. So that means that we could graph the displacement as a function of time. We could do a displacement time graph. So that displacement time graph would look like this. So it's being described by this quadratic, or this parabola. So at 0 seconds, it was on the ground. At 2 seconds, it was at about 40. At 4 seconds, it was about 80 meters above the ground, and then it came back down. Now, it's really, really important that you're not mistaking this graph as a graph of the ball's path. The ball was moving straight up and straight down, but this is our displacement and this is our time. So we've got a distance time graph. So you can see it starts off fast and then it slows down and then it starts falling back down to the ground again. So what we can read off here is that 8 seconds later, the ball was on the ground again. At 4 seconds, the ball reached its maximum height of 80 meters. So we can read off these restrictions. So our time is only going between 0 and 8 seconds, and our displacement is between 0 and 80 meters. So a lot of the questions that you'll be solving in this course will have restrictions like these, especially this part here. So it's sort of a convention of the course that we don't consider negative time values unless this question specifically tells you to. The next definition we need is for velocity. So velocity is a measure of the rate of change of displacement with respect to time. So how the ball is moving, the position of the ball with respect, or the particle, with respect to time. So the average velocity of a particle is finding the gradient of the chord of the displacement time graph. So we'll have a look at that in a second. If you don't have a graph, we can calculate the average velocity by looking at the change in displacement divided by the change in time. So let's jump back and have a look at our ball being thrown example again. So if we look at our parabola again, at our displacement time graph, say we wanted to find the velocity, so the average velocity, over the first 4 seconds. So originally the ball was down here at 0 meters. After 4 seconds, the ball was at 80 meters. So we're going to look at the change in displacement over the change in time. So this is in the first 4 seconds. So our average velocity would be equal to the change in displacement, what was from 80 to 0, so that would be 80, over the change in time, which was 4 seconds over 0 seconds, so that would be 4 seconds, which will give us an average velocity of 20 meters per second. So that it can also be seen as if we drew a straight line from this point to this point. Oh, mine is not very straight. But if we drew a straight line there, we could find the gradient of that chord joining the 2 points, and the gradient of that straight line would give us our average velocity. Let's have a look at another example. So let's say we wanted to find the average velocity in the 5th second. So in the 5th second doesn't mean in the first 5 seconds, it means in the 5th second. So that's going from the 4th second to the 5th second. So we know that at 4 seconds, our velocity is 80. We need to find in our 5th second. So to do that, we need the equation. The equation that was given to us to describe the displacement with respect to time was x equals 5t outside of 8 minus t. So that was given to us back in the original question. So we can now use this to discover displacement at 5 seconds. So if we substitute 5 into both of these, we would have 25 times 3. So that would give us a displacement of 75 meters after 5 seconds. So that means that our average velocity is going to be 75 minus 80. 80 over, so 75 minus 80 over 5 minus 4. So that would then give us minus 5 meters per second as our average velocity. So the reason that that velocity comes out to be negative is because by this stage, in that 5th second, the ball is falling back down again. Okay, a few more definitions. So distance refers to the total distance that's traveled by the particle over a particular time period. So it's different to displacement. Displacement is saying where is it relative to where it began, whereas distance is just talking about how far that particle has traveled. So because we're talking about how far something's traveled, it can never be negative. It either has to be 0 or positive. Okay, our next definition is average speed. So average speed is the distance traveled divided by the time taken. So because distance is always positive and time is always positive, then the average speed can never be negative either. So let's have a look at some examples, going back again to that example of the ball being thrown straight up. So we've got this ball again. Now, if we look at the displacement after 8 seconds, the displacement of this ball, well, it was at 0 meters and it is now at 0 meters. So the displacement would be 0 meters because relative to its original position, it hasn't moved at all. It's back exactly where it started. Distance, on the other hand, it's gone up 80 meters and it's come back down 80 meters. So over those 8 seconds, the distance it's traveled is 160 meters. So you've just got to be careful between the difference between distance and displacement. You also need to be careful with the difference between speed and velocity. So if we look at the average velocity over those 8 seconds, then we'd have the average velocity would be equal to, we're talking about the height first, so the displacement. So we'd have 0 minus 0 over 8 minus 0, which will just give us 0 meters per second as our average velocity. But our average speed, we'd have the distance traveled, which we just said was 160 because it's gone 80 meters up and then 80 meters back down, over those 8 seconds, which would give us 20 meters per second as its average speed. So just being really careful between displacement and distance and velocity and speed and the differences between those couple of things.